Hi friends, this is Dr. Adarsh Mungal, working as Assistant Professor, Department of Mathematics, Engineering College Ajmer. Today we will discuss about ordinary differential equations with a special context to its order and degree. We will study about what is an ordinary differential equation and how one can determine its order and its degree. So let us start with ordinary differential equation. What does it mean? An equation which contains an independent variable, say x, dependent variable, say y, and differential coefficients of dependent variable with respect to independent variable, say dy upon dx, or it may be denoted as y1 d2y upon dx square, and it is y2, and so on. If x, y and these differential coefficients are involved in an equation, then it is known as differential equation. Some examples are as under: y2 is equal to 9x, y1 is equal to sin x plus cos x, y is equal to xy1 plus square root of 1 plus y1 square, and another one is cy2 is 1 plus y1 square raised to the power 3 by 2. In all the four examples, we have assumed that y is a function of x, so that y is treated as dependent variable and x is independent variable. Here y1, y2 and so on denote the differential coefficients of dependent variable y with respect to independent variable x. Let us one more thing which should be keep in mind while solving the differential equations. Basically, differential equation can be classified into two categories. First one is ordinary differential equation and second one is partial differential equation. When number of independent variables in an equation involves more than one, then partial differential equation come into the force, which is beyond the scope of the today's topic. We'll discuss it later on. Now we come to find out order of a differential equation. What is it? The order of a differential equation is a positive integer always. It cannot be negative and zero. So let us define what is it. The order of an ordinary differential equation is the order of highest order derivative involving in the equation. Highest order derivative means the number of times the y differentiated with respect to x. We have to finalize it how many times y differentiated, and the order of that is said to be order of a differential equation. Let us take some examples to find out what is the order. For instance, y2 plus 3y1 plus 2y is equal to e power x y3 square y1 power 4 plus y square equal to 0, and y plus y1 is equal to 1 by 2 integral y dx. In the first equation, the highest order derivative involving in the equation is y2, means d2y upon dx square. Here y is differentiated two times with respect to independent variable x, so that the order of the differential equation 1 here is 2. In the second equation, the highest order derivative involving in the equation is y3, means d3y upon dx cube. Therefore, the order of the differential equation 2 is 3. Now, for the third example, here, see, the present equation involves integral sign. It is integral differential equation. So that, first of all, we have to eliminate the integral sign. To do this, we have to differentiate it. As we all know, differential and integral reactions are reversed. So that after differentiation, the sign of integral remains abolished from the equation. Now, after differentiation, we get y1 plus y2 means dy upon dx plus d2y upon dx square is equal to 1 upon 2y. Here, the order of the highest order derivative is 2, y2. So that order of the differential equation comes out to be 2. Now, degree of a differential equation. The degree of a differential equation is the degree of highest order derivative, provided that the differential coefficients has been made free from radical signs. Means it is free from square root, cube root, nth root, power 1 by 4, power 1 by 7, etc. Also, one more thing which should be noted, that if any differential equation cannot be expressed as a polynomial in dy upon dx, means derivative, as far as derivative is concerned, then degree of such a differential equation cannot be defined. It's not defined. Let us take some examples to clarify, to determine what is the degree of a ordinary differential equation. First one is y2 square plus y1 is x sine y2. The degree of the differential equation 1 cannot be defined as the right hand side function, means sine y2, sine d2y upon dx square cannot be expressed as the polynomial in dy upon dx. So that this differential equation y2 square plus y1 is equal to x sine y2. Its degree cannot be defined. Now, the second example, cy2 is 1 plus y1 square power 3 by 2. In the present condition, it is not in a polynomial in dy upon dx. To do so, we have to square both the sides to free the equation from radical sign. After squaring, we have c square y2 square is 1 plus y1 square power 3. Now, the degree of the highest order derivative is 2. As y2 is present, y2 is involved in the equation. Hence, the degree of the differential equation is 2. In the third example, y2 plus 3y1 plus 2y is equal to e power x. Here, highest order derivative is 2. Highest order derivative is 2, y2, and degree is 1, y2 power 1. So that we can determine the degree of all the three differential equations. Thanks for being with me.